Hello to everyone and welcome on this second part on our computer network. So on the first part we have discussed everything you need to know concerning IP addresses, which is a very important concept on our computer network, and we needed this knowledge for us to answer June 25 computer science. And it's another past year, a very nice question, and I think it's June 2017. Yeah, that year is also very interesting. So please, when we talk about computer science students, these are the type of things you need to master. It's not all about knowing client server architecture, knowing network devices. No, there are other parts very important for you. IP addresses, very important. So if you're following on this video, make sure that you are done with part 1, please, so that you'll be really understanding what we are doing here. So now let us continue. Let us start with the question, in fact. So June 25, question 5, okay, the Roman one. So we are starting. They say, the figure below represents a network where S, R, and H represent a switch, comma, a router, and a hub respectively. PC1 to PC5 are personal computers. Full stop. Study the figure below and answer the question that follows. So let me just draw this figure very fast. So we have this. So A, they say explain the main difference between a switch and a hub. So I've answered this question in the first part, in part 1 of this tutorial. So let me just repeat myself. A hub is a device, or let me just say a hub is a network device. Generally, I like to draw this when I'm explaining this thing. So a hub is a central device that connects computers in a local area network and performs broadcasting. Never forget that, please. And perform broadcasting. And I've explained broadcasting in part 1 of this tutorial. Good. Broadcasting here simply means when he receives a message, he forwards that message to everybody connected to him in the computer network. So if you don't want to say broadcasting, you can just define by saying that a hub is a network device that connects computers in a local area network, and when he receives a message, he sends it to all computers connected to him, if you don't want to use broadcasting directly. Whereas a switch is a network device that connects computers in a local area network also, but perform unicasting. Take note of that, please. Unicasting. Unicasting here simply means when a switch receives a message, he sends it directly to the destination computer. So the difference between hub and switch, I think, is clear. Good. Now, so we go to the next question. Before going to the next question, let me just define a router. A router. What's a router? So router, we have different way of defining it because a router have different roles, in fact, you see. But let me just concentrate on the main role of a router that will really help you in what you are doing. So you need to know that a router is a network device used to interconnect different networks. Let us say this network number 1, this network number 2. For this network to communicate with this network, we need what? We need a router. This is my router here. Take note of things like that. So this first network here can be a local area network. This network here can be a local area network. Let us say LAN 1, LAN 2. And when they say different network, I think people know the meaning of different network. Different network simply means what? That the network address of this network is different from the network address of this network. Meaning that here in this network, for example, I can have the network address here can be 192.168.0.0. So this one here, this is /16 because 16 is for the network part. I've put the host part here. Now this one can be maybe 192.168.6.0. If I write something like that, the network part is under how many bits? 8 plus 8 plus 8, because the first, remember, one decimal number is 8 bits. So this /1, this /20. Maybe some are not seeing. Let me just write it back. These markers have problems. This other network, let us say the IP address is 192.168.8.0. So this is /1, this is /24. Because if you realize very well, you will see that here I'm having 1, so 3, meaning the first 3 numbers are the network part, and the host part I've put it to 0. And remember that this is how we do to obtain what we call the network address. Take note of things like that, please. So you are seeing that the network part of this one and the network part of this one is very different. And for you to understand what I'm doing here, you need to watch part 1 of this chapter, computer network. Don't jump and watch this video without looking at the previous video. But if you're understanding this, fine, good. Now, so we continue. So this is what we call a router here. Now, take note of that, please. So a router is a network device used to interconnect different networks. Now, let me just show you something. This is my network here. I'm having a switch, I'm having a router, I'm having a hub. So by the moment you see a router, any line leaving a router and going somewhere, just know that this is going to one network somewhere, this is going to another network, because the aim of this one is to connect different networks. Take note of things like that. Now, this other side here, you see that here we're having a hub. A hub here is connecting computers in the same network. That's why when I was drawing hub and switch here, I was indicating hub and switch here, I told you that they're inside what we call what? A local area network. Take note of things like that. So it means that this and this is one network. Even here, a switch connect computers in the same local area network. So this another network here. But down here, this another network just having one computer. So the total networks that we have here is 3. Take note of things like that. Now, I think let us jump into our questions. Good. Meaning what? And the next information I want you to note is, we did in tutorial number 1, we did broadcast address, and we did network address. So we know that, okay, network address used to identify each network. That's why we have no problem. Broadcast address is an address used to send a message to all computers connected in the same network. So what is the meaning of that? It simply means that this is one network. If one PC send a broadcast message, that broadcast message will be received only by those connected in this same network. So this broadcast message will never come and cross this router and go somewhere. It's impossible because router connect different networks. So and we cannot take a broadcast message from a network to send in another network. It's not possible. Why? Because when we talk about broadcast address, the network part is not changing. The only part that changes is the host part that we are filling with 1111, meaning 225, 225. We did that one together. It's very clear. So please take note. A router will never forward a broadcast message. Never. Never and never. So their question like that at June 17, they will ask this: can PC2 communicate with PC1 through a broadcast address? The answer is no, because PC2 and PC1 are not in the same network. This is one answer. The other one, the answer is no, because a router does not forward broadcast message. Router destroy broadcast message. Take note of things like that. Maybe they ask, can PC1 and PC2 communicate through a broadcast message? Yes. If PC1 send a broadcast here, everybody connected to this field will receive that message. So these are little information you need to know. Please, very important. Another information they can ask: how many networks are we having here? We have something like that. And the next information I want to give you is, I saw this in 2017. If they do something like this, a router, then they put a router here. Place two routers connected together simply mean that there is a network here in the middle. Even if they don't tell you that it's a network, just know that it's a network. Mean that if I'm having something like this, I need marker. If I'm having something like this, then I have something here. Let us say I'm having PC1. Here I'm having PC. So, and the question asks you, these figures contain how many networks? The answer is 3, not 2. Because someone will come and say, okay, this is one network, this is one network. No, two routers connected directly together simply mean that there is a local area network here. Just that the question did not explicitly precise it. Take note of that. So this one trick in question, especially that June 17. So many people were failing that question because of this thing. Take note, please. Two routers connected together directly like this, there is a network in between. So with what I've explained here, go and answer June 2017. You have no stress there. The question will be very easy for you. I've explained everything you need to answer concerning that year. Now, but this 2025 is not all. Let us continue with the next question. The B part, they say, state and explain the most suitable network architecture that can be used in this network. So the most suitable architecture that can be used here is a client-server architecture. You know, a client-server architecture, in fact, is an architecture where we have a powerful computer called servers that manages less powerful computer called what? Clients. And generally, the advantage of this type of architecture is to allow central management, meaning that from a central device, we can manage all the other devices in terms of security and so on. Take note of things like that. So this is the answer that you give here. So let us move to the next part. I don't want to waste time. The C part, they say this: PC3 send a simple broadcast message over the network. So this PC3 here is going to send a broadcast message just over the network like that. Now they say, which computers will receive the message sent by PC3? Explain why. The answer is very clear. Just analyze. In PC3, because PC3 is sending a broadcast message, and from this figure, you are seeing that PC3 is alone in his network. So the broadcast message cannot be received by other PCs. So the answer here is very easy. You just say that no PC will receive the broadcast message sent by PC3. Why? Because the router destroy broadcast messages. One answer. Another person can say because PC3 is not in the same network with the other PC. So you see that when you master it, there are different ways you can answer the question. So we are done with that one. 3 marks. 3 marks. Now, the G part, they say state the layer of the OSI model in which each of the devices, switch, router, and hub operate. So what you need to understand here is that the OSI model, in fact, is a 7-layer model. When you say 7-layer model, it is a model made up of different layers. And these layers describe how a message is moving from a sender to a receiver. So the aim of the OSI model, in fact, is to manage communication between sender and receiver. So as easy as that. So in this video, we don't have time to study each layer in detail. No, I'm just going to list the different layers. Make sure you go and revise them. Any problem, just take and we'll see how to handle it. So the OSI model is made up of 7 layers. And never forget that these 7 layers, in fact, describe how data are being treated before it moves from sender to receiver. Take note of things like that. So the 7 layers here generally is arranged from top to bottom, meaning from layer 7 to layer 1. Now, layer 7 here, we have what we call the application layer. Layer 8 here, we have what we call the presentation layer. layer layer 7, layer 6. Now layer 5 is what we call the session layer. The session layer. Layer 4 is what we call the transport layer. The transport layer. Layer 3 is what we call, because we are done with transport layer, layer 3 here is what we call the network layer. The network layer. I have problem with Mac. The network layer. Layer 2 here is what we call the data link layer. And layer 1 here is what we call the physical layer. Take note of things like that. So let me just briefly explain this in 1 minute. Now, application layer is a layer that provides services. So you have your notebook, you can take note. Application layer is a layer that provides services for user application. For example, when you're using something like your web browser, you want to access a web page. Generally, the service that gives you that web page is what? The protocol HTTPS or HTTP. Are you there? Good. When you're sending emails, you're using the Gmail application. Generally, the service there is what? They call that protocol Simple Mail Transfer Protocol. So this application layer, in fact, is providing you these services, in fact, for this user application. Take note of things like that. Play the whole of this one. Now, presentation layer. Generally, presentation layer is dealing with what we call the format of the message, encryption of message. So anything dealing with the format of the message and security about that message is handled at the level of presentation layer. When we talk about format of the message here, let me just take the case of encoding. Encoding here simply means that we are putting a message in a format that will be understood by the device that will receive the message. I think you are getting that. Generally, this for compatibility. That's why you are seeing someone having iPhone can communicate with someone having Android phone and so on and so forth. Simply because we are having a standard encoding in such a way that each device can communicate without any problem. Now, encryption here simply means that you are transforming that message into a particular code so that hacker cannot intercept a message and so on and so forth. So all this happens at the level of what? Of presentation. Now, sessions here is used to establish what we call, let me just call it a communication channel between the person that communicates. It's like when you are starting a phone call. It's like when you start a phone call, what you are doing is you are starting a session. You see, by the moment that you are discussing with someone, a session is open. And you are seeing that when you are discussing with someone, what happened? Normally, you're supposed to get what the person is saying and so on and so forth. So there are protocol managing this session and so on and so forth. So the session layer is dealing with the starting of a session, the managing of a session, so that things should be working normally when people are discussing, when people are communicating. And it's also handling what we call the closing of the session. So this is just a way of explaining so that you get the meaning of session here. Good. So we are done with presentation session. Now, transport layer. Transport layer, this layer is there to establish end-to-end communication between devices. Generally, when two devices want to communicate, there are different protocols that enable that communication, so that things should happen very well. Like maybe, I don't know, for example, when you're doing telephone call, sometimes you may talk and someone is not receiving exactly what you are saying. Let us say you say good morning and the person receives just good morning have disappeared. You see, good. Or when you text someone through WhatsApp, you realize that if you text good morning, automatically the text good morning will arrive there. Simply because communication call and communication through text, they are different. In fact, meaning we have different protocol managing the communication. So concerning end-to-end communication between devices, this is handled by what we call the transport layer, and we have protocol that handle it there. Let me just mention some protocol. We have TCP, and we have what we call UDP. So these are protocols that handle communication at the level of transport layer, and they work differently. So in another video, I can explain in detail how they work. Now, the network layer. So the network layer, this layer is providing what we call IP addresses to devices. I've discussed about IP addresses. So it's at the level of the network layer that we assign IP address to devices. And the role of an IP, let me just off this. And the role of the network layer is to allow what we call routing of packet. Routing of packet. So let me just briefly explain what is routing of packet. So generally, when you are sending a message to someone, let us say I'm in Yaoundé, I'm using Orange network, I'm here. I want to communicate with someone maybe in Douala. So generally what happens, if I'm using Orange network, maybe he's using, I don't know, MTN or maybe Orange also. So yeah, for me to communicate with this guy, you are not in the same network. He's somewhere else, I'm somewhere else. You are not in the same network. And generally, you know that for communication to be possible between people in different networks, we need what? We need what? Routers. We need routers. But now the next thing you need to know also is that don't think that it's one router that is generally between people in different networks. No. Sometimes you have even thousands of routers between two people communicating together. So now, if you have many routers like this, many routers, good. So the question is, which layer is dealing with the transportation of a message from one point, passing through a different router and so on, and reaching the destination? So it's the network layer. That's why we talk about routing of packet. Routing of packet simply means what? Taking the packet from one location, sending it to another location, passing through the different routers. And when the packet is passing through different routers, so many things are also happening here. I don't want to enter in detail there. That one is pure network. Good. And sometimes also we have different routers. How will the packet, maybe generally this message we call them packet, how will the packet know the shortest path to reach the destination? There are so many other things that enter into detail. But just know the network layer is used to what? For routing packet, for the routing of packets, good. And generally we use what at the level of the network layer, IP addresses. At the level of the data link layer, we are using with MAC addresses. So Data link layer is just managing communication in a local area network. Take note of that. In local area network like when you're having this style topology, the switch is used in a local area network and it's working with MAC address to send messages all connected to the same network. Take note of things like that. So we go to the next one, physical layer. So the physical layer, this is where data is being transferred through physical medium. You see, so data here is being transmitted in the form of bit. Good. So the physical layer, this is where data is being converted into bit for transfer through a physical medium. So I've explained all the 7 layers very, very easily. Now, the next thing you need to know some of the network devices found in some of these layers. So let me just mention some, not all. At the level of the transport layer, here you have firewall. Firewall. Good. A firewall is just a security network device used to block unauthorized access to a network. Good. You have different definitions because firewall here is not always a device, but in case of computer network, you can take it as a network device. So here we have firewall, take note please. At the level of network, here we have things like a router. Good. There's another device we call layer 3 switch, but I don't want to confuse anyone here. So just another transport here, you have firewall, network here, you have router. Data link layer, here you have different devices, you have switch. Very easy to retain. We also have what we call network interface card. It's found at the level of data link layer. We also have switch. We have network interface card. We have bridge. A bridge also. Good. If you don't know the definition of all these network devices, please just search them somewhere. I don't want to waste time defining each of them. The video will be too long. So bridge, switch, network interface card. At the level of the physical layer, please take note. We have the hub. We have repeaters. These are also network devices here. So that's why I was saying that one thing very important on the computer network is to know the definition of all these network devices. We have hub, repeaters, we have cables. Good. So please, I think I did a lot concerning all these things. So this is what you need to know concerning the OSI model. The next question that they can ask in the exam is, give the TCP/IP model. So what you need to know is that the TCP/IP model is just a summarized version of the OSI model. And this summarized version is either made up of 4 layers or 5 layers. Take note of that, please. Either it's made up of what? Of 4 layers or it's made up of 5 layers. Now, when it is made up of 5 layers, let me start with this first situation. When it is made up of 5 layers, generally this is what happens. My marker. 5 layers simply means that the application, presentation, and session layer are combined into a single layer called the application layer. Meaning that when you are drawing the TCP/IP, you just start directly layer 5, you write application layer. Then you go jump directly to transport layer, network, data link, physical. Take note of that, please. Good. Meaning layer 5, you write application. Layer 4, you write transport. Layer 3, you maintain the order. So this when you are using what? 5 layers. When you are using 4 layers, the same thing. This first 3 layers is also renamed as what? Application layer. The other thing you need to know is that when we are binding these 3 layers into one layer called application layer, this application layer is handling all these 3 functions at once. Take note of that, because some people may think that we are eliminating this. No. Okay. So now, when the TCP model is having but 4 layers, the same procedure, you combine this first 3 into one layer called application layer. Now, the next thing is you leave the transport layer like this. Now, the network layer, generally the name changes. So let me just clean something here. The network layer, the name will change to what we call internet layer. Internet layer. Good. But even though it's not important, even if you leave network layer, there's no problem here. But what you need to note is that when it is 4 layers, the last 2 layers, meaning data link layer and physical layer, the name change. These 2 layers have now a new name, and that name is called network access layer. Take note of things like that, please. Good. So when you have 4 layers for TCP/IP, the first layer is what? Application layer. Good. And that application layer is a combination of what? Application, presentation, session of the OSI model. Now, after that, having that layer, I mean, you call that layer 4. Now, layer 5, layer 3 is what? Transport layer as normal. Good. Layer 2 is what? Layer 2 here, you call it now internet layer, or you just leave the network layer, there's no problem. Layer 1 now here, you call it network access layer. And network access layer is a combination of what? Data link and physical layer, because these are simple questions they like to ask. Good. But when they ask TCP model with 5 layers, don't stress yourself down here. Just mix these 2. Just combine these 2 into one layer. So just start directly with 5 application layer. So we leave the rest like that. Go. Take note of things like that, please. So I've covered everything under the OSI model, TCP model. So this is what you need to know for your exam. So let us go back to our question. If you go back to the question, they say state the layer of the OSI reference model in which each of the device, switch, router, and hub operates. It's clear now. The switch, let me start with the router. The router operates where? At the level of the network layer. The switch operates where? At the level of the data link layer, and the hub at the level of what? The physical layer. You have all your marks. It's easy. So we go to the next question. The next question here is, is still under IPv addresses. So I want us to answer that next question in another video, because there are certain things I want to mention there. If I continue here, the video will be very, very long. So this is where we are ending for this tutorial. So if you have enjoyed everything, leave a comment. Any question, any misunderstanding, please just ask in the comment section. I will reply to you. So now let us meet in the next tutorial for the last part, which is Roman 2. There is another concept I need to explain before answering the question. As I'm telling you, I'm not just answering the question, but I want to explain in such a way that tomorrow when you have your own question, you are able to answer it without any stress. Take note of that. So ciao, see you in the next video.